All right, we're back. We're actually about to finish our unit with all this trig stuff. Okay, and again, I don't know why people try to make this a lot harder than it has to be. Okay, did you just give me the ex-wife look? Yeah, she sit there and went like, if she had lasers, I'd be kind of holy right now, and it's not even Sunday. Okay, so um, but trust me, I have taken all this other stuff I've seen and made it really easy. Okay. So also don't forget, hit subscribe, hit like, hit the bell, leave a nice comment. All right. So area of triangle, the angle of triangles. Okay. So the area can be found by saying 1/2. Used to you would say like 1/2 base times height. Well, we're going to have these really funky uh, triangles that doesn't have a height. We're not going to draw it, all that kind of stuff. Basically, it's going to be 1/2 a side times the side times the angle, the sine of the angle between the sides. Okay, that's like if we're given this and this and this angle. Okay, there in the textbook that I don't let y'all see, there are 3 different examples of this, and all they do is change the letters. So that's why I had it all typed out and I was like, bump that. Okay. So that's really it. Now, again, make sure that you're choosing the angle between the two sides. This is similar to when you use the law of cosines. That may be important for homework later today. All right. So on this example, I think there's like maybe 4 questions on the homework today. Yeah. All right. So find the area of a triangle, round to the nearest tenth. That's important too. Round to the nearest tenth. Okay. What are our two sides in this? Yeah, 19 and 17. Okay. What's the angle that's between them? Okay. That's the problem. So we just plug it in. Okay. All right. So I'm going to say 0.5 times 19 times 17 times the sine 135. Okay. Now, you don't actually have to do the 1/2. You can do the decimal because that's a smart thing to do. If you're, doing I can't, fat fingers. Okay. And I just do parentheses. Okay. Because the calculator should know, using basic order of operations. Okay. So I get 114.19. Okay. So 114.19. All right. If I'm rounding to the nearest tenth, that means I look right here. Okay. That is bigger than 5. So I'm actually going to say my area is 114.2. Now, I'm not going to make you put units squared or anything. I'm like meters, yards, hectokilometer. No, I'm not going to do any of that. What? What does the directions say? The directions say round to the nearest tenth. So if you just put 114 down, I'm going to take off some points. Okay. Now, how difficult was that? Pretty difficult. I mean, super duper crazy hard. Okay. Basically, you're given two sides and an angle. You say 1/2 times the side times the side times the sine of the angle. Bam. That's it. Okay. All right. So for these two, these are practice. Now, this does not have a triangle set up. Does it really matter? No. Okay. Because, I'm just going to go ahead and write 0.5 for 1/2. All right. Our two sides are 19 and 14 and the sine of 60. Okay. Because I'm given two sides and an angle. I just kind of, have y'all noticed a pattern this week? It's like, oh, this is what you do. You plug this in here. Interesting. Very, very interesting. Okay. So times no, times 14 times sine of 60. All right. I get 115.18. All right. And the directions say round to the nearest tenth. So look here. So this is 115.2. And what happens if you don't put the 0.2? You get points taken off. And you get your name taken off the good noodle board. If I actually had a good noodle board, I think that would be the most hilarious thing in this class. I might have to work on that. Also, might want to not work on it because I would find something better else to do. Okay. I am so much like y'all. I mean, I know when y'all leave here, y'all don't want to do anything school related at all. Okay, I don't either. Okay, there's our sides, there's our angles. Also, a little thing that you may want to make sure that your calculator is in, you want to make sure it's in degree mode. You can usually see it by it saying DEG. All right, we get 285.55. So this is 285.55. That would round up to 285.6. Okay. Now, we're looking at it at its bare bones part of it. Hey, I'm given two angles and a side. They say find the area. Okay, I plug it in with this formula. Okay, that's really it. And a lot of your math problems that you're going to have are situational. Okay, you might have to do something else, blah blah blah. But if you have this information, you should be able to find this area. Okay, like if I don't know, if I wanted more of my gray in my beard to go away, I would use something to dye it, right? Okay. Or quit teaching and then all my hair would come back. Okay. Now, wouldn't that be funny if y'all see me after I retire and all of a sudden I've got like long hair and flipped around and like a beard down to here? That'd be amazing. All right. Does everybody have this up to now? Copy down. I tried to filibuster. Okay. So the next little part. All right. Here's the thing. I found somebody smarter than me, which is not really hard to do sometimes, but I found somebody smarter than me and asked them about this. And they said, yes, what you're thinking is exactly what you should do for this class. And I was like, awesome. Okay. Now, previously on the board, it said you will also need your unit circle sheet with all the coordinates. Okay. And this is why we only have to solve very simple trig equations. Okay, very simple. I'm not going to do like 3 sine x blah, 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 blah. No. Okay. So let's think about this. It says the sine of x is 1/2. Remember, sine is our y value, right? The rocks in the head go rattle, 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 rattle. What? No. Cosine's the x coordinate. All right. So, what are the radians that have a sine of 1/2? Well, since I don't see any pink sheets with people's unit circles out there. Oh, got one. That's still a pink sheet. No, I'm okay. Where it was there we go. Okay, so let's look over here. Because that 1/2 is positive, that means it's going to be in the first and second quadrant. Okay, what two radians, that means the pi over a number, has a y value of 1/2? Pi over 6 and 5 pi over 6. See, pi over 6 has a y value of 1/2. 5 pi over 6 has a y value of 1/2. So guess what? That's our answer. Yep. Pi over 6, comma, 5 pi over 6. That's it. Wow. Okay. Now, this right here, our cosine, that's our x value, x coordinate. Okay. This has a negative. Okay. The only in our unit circle, remember these are both positive. This is negative and positive. These are both negative, and this is positive, negative. Okay. Where, what quadrants are this going to be where our x value is negative? Yeah, 2 and 3. Very good. Okay. So that would mean it is 3 pi over 4 and 5 pi over 4. If I could get past this advertisement, there we go. 5 pi over 4. Okay. So that's our answer. 3 pi over 4, 5 pi over 4. Man, isn't it? Please do not bite your sister in class. I have snacks if you are hungry. Please do not revert to cannibalism. Oh, I can just somebody's going to reply, "Show us the cannibal." Okay. All right. So, all right. Now, how difficult does that seem? You're listen, I have made it so simplistic that you are still getting confused. Like the only thing I'm not doing is like making the airplane noises. I'm spoon feeding y'all. Okay. That would be funny though. All right. So now remember, we're in this part right here, this zero between 0 and 2 pi, because we're actually looking for stuff on the unit circle. Okay. If we were looking on something else, we would be looking at coterminal angles. It doesn't matter. It's all the same thing. Just you add a number of by the pi. Okay. All right. Sine of 1, that's our y coordinate or value. Okay. What has a y coordinate of 1? Close. Keep going. Well, think about it. If this is 0 and pi is all the way over here, what would halfway in between be? Pi over 2. That's our answer. Crazy. Wow. Okay. So cosine, this is our x coordinate, is 3 pi over 2. All right. So this is positive. That's a positive x. So it's going to be in 1 and 4. All right. So if you don't have it memorized, well, oh, look, this is pi over 6 and 11 pi over 6. Huh. So pi over 6. And what did I say? 11 pi over 6? Yeah. Uh-oh. There's a tan in there. Who remembers, it's probably going to be very few, what tangent is? It's something over something else. Sine over cosine. Very good for the 2 points for the cannibalism. Okay, so sine over cosine. Okay, so basically we are looking for something that has a sine of 0. It doesn't matter what the cosine is. It could be 1 or -1. Okay, so what do you think is going to actually have sine over cosine of 0? Where is sine 0? Yeah, okay, it's 0. 180 is what? Pi. And if we make it all the way back around to 0, that is 2 pi. All right. So, again, do y'all want it more difficult? Oh, y'all missed it yesterday when I was, huh? What did you just say? No, I said y'all missed it. Y'all missed it yesterday. Listen, I speak slow enough with the country slang that you ought to be able to understand. Okay. When I was actually uploading the video to YouTube, I put on the description what it was and put no fluff, but all good stuff. Wow. It is. All right. Now to the back. Shh. Now, shh. So, quick question. What is the Pythagorean theorem? A squared plus B squared equals C squared. Okay. Now, we're actually going to explore. Notice I said explore. One Pythagorean trig identity. And this is what it is. You ready? Y'all better put on your helmets. I'm about to blow your mind. Okay. That's sine squared theta. That's the best way I know how to write theta. You know, it's the 0 with the little dash in it. Some of y'all are looking at me like I'm speaking a different language. I mean, I can, you know. Okay. Ooh, voice crack, second puberty. Now, This is the one we're going to explore. Okay. Y'all, y'all, okay. Yes. Okay. So, why do you think it's called the Pythagorean trig identity? How is this purple equation and this red equation related? Okay. Two squared things equal something. I'll take that. That's on the right path. All right. If this was our triangle right here, which it is, lovely triangle, what did we talk about? And this would be our what value if we were drawing this on the unit circle? Well, yes, but what value? Your y. Okay. And what did we say our y was? That was our sine. Okay. Now, this would mean this would be our x value, which is our cosine. So look, all they really did, and they make a big hubbub about it, they just plugged in, oh, well, if we use sine as our y and this, basically, I could ask you to say, show me the trig identity for this coordinate. Okay. You would actually take that, square it, plus the other one, square it. It's going to equal 1. Okay. I don't think I'm going to do that. Okay. All right. So why do you think it's called the Pythagorean trig identity? So you got to speak louder. Say it again. They literally just plugged in sine and cosine. Okay. They plugged in stuff from the unit circle. All right. Now, wouldn't that, don't you know that you would just love to sit there and do this stuff constantly to pass your time? Well, if you didn't have the Tic Tac, the Instaham, TubeBube, and stuff like that, the Netflix, no, the Netflix. I don't say it correctly. I call it the Netflix. I said the Netflix. Okay, I'm gonna have to stop this recording because apparently there's about to be a bloodbath. I'm gonna have to start picking up students and beating other students with them. Okay, but that's all of our lesson for today. Now, believe it or not, we are actually done with this part of chapter 8 that we're going to have a test on next Tuesday. So if you want to come by to take the test, let me know. Okay, email me. I can probably send you a copy. If you're a teacher that's bored and needs some extra stuff, let me know. I'll share. It's okay. All right. Hey, I don't know if other teachers tortured their students, but I had 78 people watch my one of my videos from 2 weeks ago, and I don't have that many students. That means other students were watching it to try to learn. All right. So don't forget, hit subscribe, hit the like, hit the bell. Good stuff, good things. Roll Tide.